All right, now we're going to do number 2 of solving, practicing Cramer's rule. So the first thing we need to do is take our matrix and turn it into an augmented matrix C. So we have 2, 3, 1, 11, 3, 1, -2, -1, 1, -2, 3, 6. Okay. In order to solve for our matrix, we're going to have to find the determinant of C. In order to find the determinant of C, we're going to have to write the determinant. 2, 3, 1, 3, 1, -2, 1, -2, 3. Then we take the first two columns and we rewrite them next to it. 2, 3, 3, 1, 1, -2, and now we can solve for our determinant. We start with our downwards diagonals. One moment. Let's move that away so I can write on my screen. All right, so we're finding the downwards diagonals. 2 times -1 times 2. Just kidding. 2 times 1 times 3. Make sure we're doing this the right way. 3 times -2 times 1. 1 times 3 times -2. 2 times 1 times 3 is 6, plus 3 times -2 times 1 is -6, plus 1 times 3 times -2 is a -6. 6 minus 6 minus 6 is a -6. Now we will do our upper diagonals. 1 times 1 times 1 plus -2 times -2 times 2 plus 3 times 3 times 3. 1 times 1 times 1 is 1, plus 2 times 2 times 2 is 8, positive because there are 2 negatives, plus 3 times 3 is 9 times 3 is 27. 1 plus 8 plus 27 is 36, right? 36. Now we can find the determinant of C. Back in my rainbow pen. It's going to be -6 minus 36, which equals -42. Now we are going to go and find X. So first we need to write the matrix so that we can utilize Cramer's rule. So we're going to take our X's and we are going to replace them with our answer column. So we're going to put our 11, -1, and 6 in the X column. Everything else will be as written in the original matrix. So 3, 1, -2, and 1, -2, 3. Because we're solving for the determinant of this matrix, we're going to copy our first two columns again at the end. 11, 3, -1, 1, 6, -2, and now we can find the determinant using diagonals. The downwards diagonals of the first one, just kidding, 11 times 1 times 3 plus 3 times -2 times 6 plus 1 times -1 times -2. 11 times 1 times 3 is 33, plus 3 times -2 is -6. -6 times 6 is a -36. Plus 1 times 1 times 2 is 2, and 2 negatives equal a positive. This will be 2. I'm going to add all of these together and I get -1. Now we can find our upwards diagonals. 6 times 1 times 1 plus -2 times -2 times 1 plus 3 times -1. Oh, this isn't a 1. This is an 11. I'm so sorry. 2, 2, 11. 3, -1, 3. 6 times 1 times 1 is 6, plus 2 times 2 is 4, times 11 is 44, minus, because this is going to be a -9. 6 plus 44 minus 9 is going to be 41. I'm going to use this to find the actual determinant of x, which is going to be -1 minus 41. If I take 1 and minus 41, I get -42. Now I'm going to use that and the determinant of c to find the actual value of x. So x will equal the determinant of x divided by the determinant of c. The determinant of x is -42, and the determinant of c was also -42. 42 divided by 42 is 1, negative divided by negative is positive, therefore x is 1. We are now going to go solve for y. Remember, to solve for y, we take our y column and we replace it with the answer column. So we're going to write 2, 3, 1, 11, -1, 6, 1, -2, 3. And because we're finding the determinant, we're going to copy the first two columns onto the end. 2, 11, 3, -1, 1, 6. Now I can find my determinant. My downwards diagonals are first 2 times -1 times 3 plus 11 times -2 times 1 plus 1 times 3 times 6. 2 times -1 times 3 is -6 plus 11 times -2 is -22 plus 1 times 3 times 6 is 18. -6 minus 22 plus 18 is going to give me a total of -10. I didn't have that one already written down. The upwards diagonals are going to be 1 times -1 times 1 plus 6 times -2 times 2 plus 3 times 3 times 11. 1 times 1 times 1 and a negative is -1 plus 6 times 2 is 12 times 2 is 24 and negative wins plus 3 times 3 is 9 times 11 is 99. -1 minus 24 plus 99 is going to give you 76. I can use this to find the determinant of y, which is going to be -10 minus 76, which gives me -86. I feel like that should be -74. I made a mistake somewhere. -6 minus 22 plus 18 is -10. 1 minus 24 plus 99, 74. There's a mistake. It's that and that and that. 84, and this was 74. Sorry, guys. Now that I have my determinant of y, I can use that to solve for the value of y. The determinant of the value of y is the determinant of y divided by the determinant of my constant coefficients. Just my coefficients, just kidding. Determinant of y is negative 84. Determinant of the coefficient matrix was negative 42. Negative divided by negative is positive. 84 divided by 42 is 2. Last, but certainly not least, is going to be z. Z is found by its matrix, taking out this last column and replacing it with my answer matrix. 2, 3, and then, 2, 3, 1, 3, 1, negative 2. And then my answer column for Z is 11, negative 1, 6. Because we're doing the determinant, we need to make sure that we are copying the first two columns, 2, 3, 3, 1, 1, negative 2. We're going to start by finding the downwards diagonals. 2 times 1 times 6 plus 3 times 1 times 1, negative 1, plus 11 times 3 times negative 2. 2 times 1 times 6 is 12, plus 3 times 1 times 1 is negative 3, plus 11 times 3 times negative 2 is a negative 66. Calculator says 12 minus 3 minus 66 is going to give me a negative 57. I can use the upwards diagonals next. 1 times 1 times 11 plus negative 2, negative 1, 2. So negative 2 times negative 1 times 2 plus 6 times 3 times 3. So I have 1 times 1 times 11 is 11 plus negative and two negatives make a positive. So 2 times 1 times 2 is 4. And all of these are positive. Therefore, I'm going to get a last positive. 6 times 3 times 3 is 54. 54 plus 11 plus 4 is going to give you 69. I can use this to find the determinant of Z, which is negative 57 minus 69. Negative 57 minus 69 is going to give me negative 126. Now that I have the determinant of Z, I can use it to find the value of Z. The value of Z is the determinant of Z divided by the determinant of the constants, the coefficients every time. The determinant of Z was negative 126. The determinant of C was negative 42. Negative divided by negative is positive. 126 divided by 42 is 3. My final solution to my original matrix, new pen. My original matrix, the final solution. Please make it very easy for me to find your answers, guys. 1, 2, 3. And that's it. So now you've solved both the first and second problem on the Practicing Cramer's Rule worksheet. If you have any questions, please message me and I will get back to you as soon as I can. Bye, guys.